Hi, and welcome to our presentation for DISC. We are very excited to be here and looking forward to come here for a long time now. This is the first time we showcase what we are doing in such an audience, and I'm really looking forward to see and learning from other companies as well while being here. My name is Kent. My background is actually electrical and instrumentation engineering. I've been managing engineering design tools for more than 20 years now, anything from Aviva and SmartPlant, etc. But my current role now is CTO in Draga. With me is Alex. Set up, yeah. He's our supporting service manager, and he has also more than 16 years of experience in programming and engineering design tools. About our company, very quickly, this is going to be a very technical presentation, so it's going to be very quick, but one slide about the company. Draga is a growing company, and quite quickly as well. We are focused in energy sector, but also chemical mining. We also have specialists within the various tools. We currently are at 3 different locations. We have an office in Stavanger and one in Sandefjord supporting the Oslo area. And we also have an office in Thailand, and only last week we opened also a branch in Singapore. You're going to see a logo with Mimstech on it, and that's our holding company for our it's the same owners as Draga, and all our solutions and software is owned by this company. Just for information. So MIMS develops solutions for, as I said, managing engineering information, and usually sitting in a company intranet or cloud environment. And for the DISC initiative for openness, Draga is already involved in a project with IMF datasheets. And we're currently also contracting a project lead to the DISC-XP initiative. Yes, so about 2 years ago, we decided to try to develop a new generation of tool to support creation of technical drawings in a web browser. As a result, the first version of what we ended up calling the dynamic render came online about 14 months ago. Dynamic render has and can use its own engineering database, but they can also sit happily on top of other structured sources, for instance from Hexagon, Aviva, Okotech, PCS, STID, or basically any other structured data source. It's a tool and a module that can sit on its own. So to conclude, yeah, and when we first started developing it, we looked, okay, what should be our initial mission and vision, and we said, okay, it needs to be 0 footprint, and in the beginning at least it needs to support algorithm driven drawings, and I will talk about that a little bit later, and basically auto generation of structured drawings. But it shall also strengthen real-time collaboration and communication in projects, and that's going to be key, we think, in the future. And after we know about the DISC, we also added another one, which we call schema-driven drawings, which is also a very big topic here today with the DEXP initiative. But we also support AML, XML, and a kind of structured format. But first, let's give an initial demo about the dynamic render. Yeah, so this dynamic render can generate lots of diagrams, but to save time, we will just show some loop diagrams today and some block diagrams. More drawing types, as you can see, are available, but we can come over to a stand outside and we can show them later on. Why is this an algorithm-driven drawing? If you see to the left of the drawing, this is a loop drawing. And in the left top corner, you can see there is an instrument. An instrument will have a terminal. Terminal will be connected to a wire. The wire will sit in a cable, and you kind of see where this is going. This is an algorithm has pieced this thing together. The leg bone is connected to the hip bone, and based on signals transmitted through the cable as well, we are able to connect it all the way up to the SAS system. This is nothing game-changing. Loop drawings has been auto-generated for 20 years, but what is game-changing here, it has been generated straight from a database in a web browser. This drawing does not exist. This is just, it has been reading information from the database, and it's been displayed in a web browser. And if you see a look around the portal around, that is not the dynamic render. What's actually in the drawing frame, that is the dynamic render. So it can be fully integrated into your own portal, intranet, cloud, whatever you need it to. So never mind the portal around it. It's a generic portal that we just use for internal development. Okay, so so while we were doing this, in midst of all, this challenge came from the Disk Initiative, and we, just to put it up on this wall, was a fairly big order, tall order, with 6 very challenging items. But we decided to take the challenge and see if we could at least come up with some sort of answer for all of them, all 6, yes? So I will demonstrate how we choose to solve these 6, using, amongst other things, this dynamic render. I will read a little bit from the PowerPoint here. It's not just to kind of set the bar. So the first one was demonstrate an end-user tool that can use the disk files to provide a viewer of a datasheet and/or a PNID. And these were the 2 files that was sent in this Dropbox, or we choose to use these 2 files. We'll give a demo for showing a PNID. And there you go. That's the DexP PNID. We can also show importing a datasheet or a data set towards one of the objects on the drawing. And if you click that object now, which is this valve, all this data from the datasheet has been coming in. So, great thing about these formats is they're 100% machine readable and can correctly graphically represent a PNID, as we just have seen. But it can also be the basis for a logical model sitting in the back, you know, enabling new features like validation, content analysis, any kind of reviews, calculation, simulation, etc. The list just goes on. And you can also feed this straight into an AI model of your choice, you know, and this really opens the future for the new world of working. So we feel that doing this, we will end the challenge number 1. For challenge number 2, demonstrate a tool that can use the disk files to solve a business use case like search and queries using equipment attributes, and search and query again using equipment attributes and PNID logic. In this frame, we will show our component explorer and look for a line. And you click the line, and immediately you can find the line. You can also see the connected valve, flanges, etc. We can also search for a tag. Find the tag, jump to the tag, and we can also search for property values.
24.
Thank you. And there we go. Next slide. This was a really tall order from our perspective. It says demonstrate or creating a file according to the standard from a PDF or a scan. We did not do this, create a file for this show and tell, but we can show what we did together with Billfinger Digital Next back in 2020, 2021. At the time, 2020, 2021, DexP only supported graphical objects and primitives, and not the more modern DexP structure. So it was quite challenging as well. we can show the video of where we're using our MIMS plugin now, and this is towards Aviva diagrams. We're running 8 PNIDs at once, converting. This was back in 2021. This project was estimated around 18,000 PNIDs. We also did another one in parallel with Hexagon, Smart PNID, where there was an estimate of total of 28,000 PNIDs to be converted using this style of DXP. Sadly, I must say, both projects failed. That was due to the gaps in the quality of the data in the source files that we got. At the same time, DXP was not ready to accept. There was too many gaps in the DXP standard. But I always ask myself, what would be the result today, 4 years later, 3-4 years later, if we had good source files and with the new DXP schema, I would comfortably say that would not be a problem at all. So for the challenge number 4, it says demonstrate importing the sample files to your authoring tool, make a change, and sharing this new version using our common format. We use the same files, they're already imported. Also, we are using the DXP verificator from the NOACA DXP GitHub. And we're also using the semantic online tool to validate datasheet dataset. For the first demo, we'll just do the datasheet or dataset. We already have it imported, so we can make a change. He makes a change now to the project name. And he exports it. This is the semantic online tool for validating. It's not working. Yeah, there we go. This is also, there came no errors. Data file has been updated, and we can search for the change we made. And there you go. Okay, we'll go back to the PNID. As again, it was already imported in stage 1 or in phase 1. We'll do a change on the PNID. We'll add change the sequence number. Move this object a little bit, maybe. Delete this nozzle. And inject a new valve into a line. And we also have to give the new valve a tag. There we go. And we have exported XP. Then this is the DXP verificator that's from the NOACA GitHub. And we run the analyzer. Not online? Okay. Oh, there we go. Yes. So we recreated the drawing inside the DXP verificator with also no errors. And you can see the changes we have made is already there. Yeah. So for the pièce de resistance, yeah? We would do a live demonstration, updating the file and showing and sharing it with another company that visualize it. Well, we have been working live all night or all day. But we will pretend Alex here is working for another engineering company. We didn't have time to work with another company in this part, so we just have to do it ourselves. And he is he's given a PNID and to update, and is using the DXP format. His company happens to be using Hexagon Smart PNID for their process engineering, and using the Smart PNID with our plugin. We will demonstrate importing the updated PNID. Due to how Hexagon tools are working with quality constraints, the whole process will take about 3 minutes, and we have 3 minutes left. So we'll skip a little bit ahead. But we used Hexagon here, but we could have used any other structured data model as well. But we had one license laying around, so it can just be easy to use Aviva or something. But we support Bentley, Autodesk, Ocotec solutions, Aviva, Siemens. So we can find plugins for both for all of them. But to wait, there was another sixth, and that was the points and cred to be given for following the same logic as over, as well as input on how to improve the data model and collaboration. Here we'll show this is almost the original DXP file. This is not the latest and greatest that is out there. This is the one that came earlier this year, and these functions are sitting on top of that. So we didn't have time to move it over to the new one. But just so it's the same drawing, and we had some time, and we started thinking, okay, yeah, now what? We have a virtual drawing, but then what do we do with it? You know, and we were thinking, okay, can we change something, and what could we change? So I said, okay, let's try to switch off. Why do we have this white and red color? Let's change the color to black and white. And that's not maybe a very big thing to do, but it kind of sets the bar or the mindset that we need to understand the next concepts, because we haven't changed anything. We have changed how we choose to look at the data. We have not changed data, anything. We just changed how we choose to look at it, and that is very important for the next steps. So we had another idea, you know, let's do maybe some commissioning features, you know, with this drawing. And we make some sort of commissioning packs where we can associate objects onto the same drawing. And this is with a commissioning hat on, and you have your commissioning role, then you can see this, but other people cannot see it because they don't have this access. But you're all working on the same data core, and the only difference is how you look at the data. And this can, and I certainly will, enable you for having multiple copies and revisions of the same drawing for different purposes. Everybody can work on the same data set, and they can validate and check, and you keep the complete data model around this core data set of the drawing. We think this, well, we're going to need you guys, you know, to tell us what kind of business cases. This is something we just made up, so we don't know if this is valuable or not, but we think so. Another thing we were looking at, maybe, okay, we can use it for review. So if you switch the drawing into review mode, and if you're a reviewer, you will see the drawing differently. Then you will see the drawing like this. This one green is approved, red is rejected, you know, and then you approve and reject objects on the drawing. Okay, sorry, we're out of time. So I will finish. Okay, just in the end, come see us out there. We're standing on the stand right outside the door. Alex, can you just show the finished PNID? There it is. Okay. Thank you.
For Draga. Thank you so much.
That was so impressive. Thank you so much. And in Norway we have something called jumping after Wirkola. So I guess next company out yeah. We were super impressed. Thank you so much.
Thank you.
You ticked all the boxes.
Thank you.
So you're on the top of the leaderboard at the moment. Yeah. I really like the commissioning case and the review case. So I think there's a lot of operators here nodding and thinking, yeah, this helps. This solves a lot of problems.